Forget about the date, but this is lesson 26. Some of you might have missed that's because of Zoom issues. So great that it's January and they decided to do an update, am I right? Totally right, Mr. Moran. What are they thinking, right? Okay, so go ahead and pause me, answer this, and let's come back and talk about it. All right, welcome back. So we've been talking about finding X and Y intercepts and that they mean something in terms when you have a word problem. Okay. We have this problem where Hayden and his brother are trying to save money. This equation represents the problem. Well, why does it represent the problem? Well, because we have two people trying to save up money for $600 so they can buy the new iPad, right? Okay. So if we're going to find the X and Y intercepts, we just think of the game tic-tac-toe, right? It's not really tic-tac-toe, but it helps us think about when we're trying to find it. So we're just going to put 0 in for Y. And you probably found that the x-intercept was 600, 0. And then we do the other one, put 0 in for x, right? And solve this, so y equals 600. So we've got our two intercepts, 600, 0, 0, 600. Now, you have to talk about what they mean, right? What's this tell us? Well, again, we're going to think about what does X mean again? X is the amount of money Hayden saves. So instead of just X, I'm going to say money that Hayden saved. And the Y is the money the brother saved, right? Hayden's brother saved. All right. So we take them separately. What does the point 600, 0 tell us? The x-intercept tell us? Well, this tells us Hayden saved all 600 himself, right? His brother saved nothing. What does the other intercept, the y-intercept, tell us? Well, this tells us the brother saved all $600 himself, right? Hayden saved 0, and his brother would have to save all 600. So that kind of gives you the spectrum of both. All right. Great. So that was the do now. Inside your notebook, you're going to give this heading, 4.3 rates of change. You've seen rate of change before. A new word in math is called slope. And we would talk about it if you're here in class. And we'll talk about it separately, but you're here. Okay. You've found rate of change in the past. Okay. But just to review, rate of change is a ratio that compares the amount of change in the dependent variable to the amount of change in the independent variable. That's it. The rate of change is how much something's changing by. The dependent over the independent. So if we had this graph right here, right, we can find the rate of change from one point to the next. Just a quick reminder, our dependent is our y-axis, right? Dependent. And our independent is our x-axis, okay? So if we wanted to know the rate of change from these 2 points, we just need to find the change in the dependent divided by the change of the independent. Well, the independent is the x, right? So if we take a peek here, we can see that our x's over here are at 1 hour, and then the next point is at 3 hours. So that's a change of 2 hours. Then we just need our change in our dependent variable, right? And that's miles. And we can see that at 1 hour it was 50 miles. Then at 3 hours it was 150 miles. So how much did that change if it went from 50 to 150? Well, that was a change of 100 miles. So our rate of change is 100 miles every 2 hours. That's rate of change. You did it in 7th grade. Now you can simplify rates of change because they are ratios. We could change 100 miles over 2. We can reduce it to 50 miles every 1 hour, right? So we have a rate of change. Okay. Here's something that we're going to connect it to. When graphing rates of change, if all the segments have the same rate of change, then they'll form a straight line, a constant rate. That's what we talked about back in lesson 23. That linear functions have constant rates of change. So that's what we got here. This rate of change when it's constant is a new word called the slope. And when we have a line in slope, it describes how steep it is, the steepness of a line. And you've probably heard of slope in other contexts, right? Or maybe not. Slope outside of math, if anyone goes skiing, they're called ski slopes, right? Let's hit the slopes, do some skiing, right? But you might have seen it in other contexts, right? But in our context, we think of it as that it's the rate of change. If it's consistent, it's called the slope, okay? And I think the idea of steepness comes naturally to us as humans, right? If I presented you with this graph or this graph, which do you think is steeper? Graph A or graph B? And you can think if you had a ball that you placed at the top of each of these lines and they roll down, right? That might help you visualize which one's steeper. Like why, if a ball was rolling here and rolling here, well, which graph would you say is steeper and why? Some students say, well, a ball rolling down here would be way faster than a ball here. And I'd be like, why? Why? And I'd be like, yes, you're right. Why would it go faster? And they're going to say, because it's steeper. And I'm like, yes, totally. But say more. Why is this one steeper? And they would say, I don't know. And then someone says, it's closer to being a vertical line, right? Like that's getting closer to being straight up and down, which is really vertical, right? Some other students say that this one's a little flatter, right? And flatter is another good word. It's getting flat, not as steep, not as vertical, right? You can think about if you were walking up this hill or walking up this hill, which one would it be harder to walk up, this hill or this hill? This one, obviously, because it's steeper. This is flatter, easier to walk on. Okay. Mathematicians wanted a way to figure out, well, we know A is steeper, but how much steeper? You know? Especially when we're talking about, like, I don't know, ramps for, like, a handicap ramp. They want them to say, hey, whoa, 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 that's way too steep. Looking at a design plan, that's even too steep. Well, how much, like, what's too steep, right? And so we need numbers to talk about steepness, okay? So we needed a way to find the steepness, and it's very similar to rate of change. So here's where I want you to add some stuff to your notebooks. This is finding slope, and we're going to add this to your notebook. So pause me now, add this to your notebook. Great, you unpause me. So slope describes how steep a line is. We're just calculating how steep it is. It's a ratio of the vertical change to the horizontal change. And I want you to add this to your notes. Delta is a word for change. I don't know if you learned that last year because of COVID, but So we just have to find the vertical change and the horizontal change, and I can tell you how steep it is. We can give it a number, okay? And here's a great example that I want you to add to your notes. So and I'm going to show you how we find the vertical and horizontal change. So imagine we want to know how steep this ramp was, right? If we want to find how steep it is, we need to find the vertical change and the horizontal change from one point to another. Okay? And all we do is find two distances. We're going to find this distance from the horizontal change from one point to the next, and then also find that vertical change. The horizontal change, that's a long word. So mathematicians thought of a much simpler word to describe the horizontal change. The horizontal change can be thought of as the run from one point to a next. And they thought of a fancy word for the distance that y is changing. We can find the rise. So if we want to find how steep a line is, we need to take two measurements. We have to find the vertical change or the horizontal change, which is the same as finding the rise and the run. Pause me while you write that stuff down. Make sure you include the sketch of the ramp. All right. So it'd be good to pause and add these to your videos, but there are 4 types of slopes mathematicians decided upon. Okay. Just because lines look differently, right? So these are the 4 types. You can add them to your notes in any way you want. Any line that goes up and to the right, no matter where it is considered to have a positive slope. As long as it's going up and to the right, it's a positive slope. We saw that in chapter 3 when it was a positive correlation. Right? Everything positive went up. Okay, another type. For lines that go this direction, down and to the right, they're considered to have a negative slope. They'll have a negative number for slope, while this one will have a positive number. It's just to show that this one's going down to the right, this one's going up to the right. This has a negative correlation, this has a positive correlation. Okay? 2 other types is like any line that's horizontal has 0 slope. It doesn't have steepness. It is completely flat. It has no steepness. So we say 0. And then there are vertical lines. I love that they added a guy falling down, right? What the heck? Any vertical line, every single one is going to have something called an undefined slope. We can't give it a number. We can't. How steep is that line? Well, it's not positive, it's not negative, it's not flat. I like to think of it as the ultimate steepness. It's so ultimately powerful, we can't give it a number. Just kidding. It's the steepest. That's how we compare stuff. Like, you can't get steeper than a vertical line, right? If it goes left or right a little bit or slant, it's no longer the ultimate steepness. So vertical lines, we can't give them a number. They're considered undefined. So hopefully you pause, maybe add this to your notes, snap a screenshot. Okay. This comes from the book. I love it. I think it's a good representation. Go ahead and read it to yourself. Pause me. I'm not going to read it to you. You read it. Okay? Okay, you unpause me. The only good thing that I would show you is that when you pick points to find the rise and run, take a look at this. If you pick these 2 points, the rise is 3 and the run is 2. But if you pick these 2 points, the rise is 3 and the run is 2. Or if you pick these 2 points, the rise is 3 and the run is 2. So what do you notice? Well, no matter what points you choose, check out, the rise and run is still 3 over 2. And that's awesome. Okay, so let's go back to this problem where we're trying to figure out how much steeper this one is from this one. Well, we have to find its rise and run. So you go ahead and pause me. My son is here. There's no way to pause this video, so I'm going to answer him, and you can always fast forward. What's up, bud? The what? Are you on a break, or are you done with school? Okay, I'll be up in a little bit. I'm almost done, okay? All right. First, these are both positive slopes, so that's good to notice. Then we just have to find the rise and run. So I can see that the run went 1, and the rise went 1, 2. So our slope is 2 over 1. If I go to this line, I can find the rise and run. The run is 1, 2, 3, 4. The rise is 1, 2, 3. So the slope of this line is positive 3/4. Okay? And you can see this slope is greater. It's steeper. It has a slope of 2. That is greater than 3/4, right? This slope is 1 1/4 greater, right? There's a greater steepness to it. Its slope is 2 over 1, which is 2. That's greater than 3/4. It has to be because it's steeper. Okay. So here's where you would do a little practice. Pause. Think about it. All right. What type of slope is this? Well, that's going down and to the right. So I know my slope is actually going to have a negative number. Okay. They already did this little box for me, so I found my rise and I found my run. So my rise is 3, my run is 2. So this slope is negative 3 over 2. Okay, in B, this goes up and to the right. It's positive slope. The rise is 1, 2. The run is 1. So I know my slope of this line is positive 2 over 1. Yeah, Mr. Moran, is that it? Yes, it is. You just notice what type of slope. This one's negative, and find the rise and run. This one is positive, rise and run. Okay? So then I would go through here. Go ahead, you find the rise and run. Pause me right now. Okay, I'm going to go. I can see that as a positive slope. The run is 3, the rise is 1. So my slope is positive 1/3. Grab the next one. Pause me. Okay, I see that it's positive. I'm going to find the rise and run. Okay, so I know that the rise is 1 and the run is 4, so our steepness is 1/4. Here, this line is less steep than this line. It's hard to tell, but it is. All right, let's keep going. All right, let's find the rise and run here. Well, it has no rise, so 1, 2, 3, 4. It has a run of 4. How do we even do that? Well, we know this is a flat line. No work to be done, yo. The slope is 0, right? It has no, it's a 0 slope. It's super flat. If you wanted to get technical, the run is 4 and the rise is technically 0. So you could write your slope as 0 over 4, but that's just 0 anyways, and you know it's a 0 slope, so you don't even have to do that work. Okay? Take a look at D. Pause me. Find me the slope. All right, let's do it. Right away, I see that this line is going down, so this has a negative slope. Okay? I just need to find the rise and run. Run is 2. Rise is 4. All right, my slope is 4 over 2, negative 4 over 2, because it's going down. All right, so your classwork is a handout. Depends on how far we went. I think for most classes I made this classwork the homework. So finding rise and run should be pretty clear, and then also identifying it. I'll just go through it really quickly. You might want to pause and then open it up and do it. But again, rise and run. Negative slope. Negative slope. Rise of 1, run of 4, negative 1/4. I know the slope is going to be 0 anyways, but I'll do it. The run is 0. Oh, sorry. The run is 4. The rise is 0. So 0 over 4 is 0, so it doesn't matter. Okay. What type of slope is this? Well, right away you know it's undefined. But we could find a rise. 1, 2, 3, 4, 5, 6. There is no run. 0. 0 over 6. Mr. Moran, why isn't that 0 slope? Right? You're like, why isn't that a 0 slope? Isn't 6 divided by 0 0? Why do we say it's undefined? Well, what happens if you put 6 divided by 0 in a calculator? Right? I'll do it. Can't divide by 0. Really? 50 divided by 0? Can't divide by 0. Yeah, you can't divide by 0. There's no number answer. Okay? On the other hand, you can do 0 divided by any number. It is 0, but not the other way around. Okay? This has a 0 slope. This has a undefined slope. This has a positive slope. This has a 0 slope. This has a negative slope. And this has an undefined slope. Okay, and if you got to 13, we're going to do more with it later. Just right now, it's just kind of like an extra problem. All right, so that was the homework / classwork.